to start with the demonstration of building a Micronaut application with Oracle Cloud. So first I'm going to go to our tooling, and you have a tooling introduction page where you can essentially learn about Micronaut and also create a new Micronaut application, which I'm going to click on. I'm going to choose my Micronaut version, the type of application I want to build, the GraalVM version I'm going to use, and in this case 11, and put a name for my application, a package, select the language I'm interested in, and select some features. So I'm going to select a few features here. I'm going to want the, for example, I'm going to want the Open API support. I think I'm also going to want some JDBC support to build this demo. We're going to want some Oracle database server support in addition to that. And I'm going to add Kubernetes support because later we're going to deploy to OKE. Click OK, choose the build tool that you want to use, the test framework, and then you can create your application, and it will automatically import into Visual Studio Code, and your application is ready to develop. So this is the structure of an application. You've got the view of the build. You can navigate into the source tree, open up the application .java file, and this is how the entry point for the application is. You can see I can already run the main class directly from here. I can click on that, and my application will start up, and I'm already up and running as a developer, which is just ideal. How quickly you can get up and running, developing applications straight away. You can also navigate into the test and run the test from here just by clicking the run button and run it. And it'll run the test. And actually, I'm going to stop this test quickly and go back to my resource factory, because by default, it's set up to test containers, but I actually have a local Oracle database running. So I'm just going to delete that, run my test again, and you'll see that my test is now using a local Oracle database that I'm running against, and it executes and passes, and everything is green, which is wonderful. So the other thing is, part of this application is you have configuration. Micronaut is cloud native, so I've got an application YAML file where I can define configuration. So I'm going to open that up. And this is where I've got my application configuration. As you can see, it's got the data source configuration in there that's connecting to the local database already set up for me. But I also get dedicated code completion provided for me from the VSCode tooling plugin. So I can, for example, type in, if I want to configure the server port, for example, I can type server host or server port, and it will come up, and I can customize the port to another port, say 8081, for example. So now I'm running on 8081, and now I can go and start my application, and all of this is available. All of the different completion options are available under there, and I can come in and start my application up. And when I start it up, you'll see, if I go back to the debug console, that now the application is starting on port 8081. So all those configuration options are automatically present and completed for the developer, so they don't have to figure them out and go and look up documentation. You just get automatic code completion, which is really nice. Okay, so I'm going to remove this for a moment and just run on the default port, which is 8080. And now I'm going to start demoing building applications. And I'm going to actually start by creating a entity class that's going to model my data. So I'm going to create a new Java class in the example package, and it's going to be called book. And there it is. So there's my book class. And all I have to do as a next step is essentially annotate it with at mapped entity, like this, just add mapped entity. And then define its fields. I'm going to define an ID, for example, database ID, maybe the title of the book, for example, maybe like the number of pages the book has. And then I can just generate a constructor, and look how the ID assists me in doing that. It just automatically generates the constructor I need, and it's already done. And what I can do then is I can also go in and generate getters for each property that I want to make accessible. So I'm going to make those 3 properties accessible, and my entity is ready to go. Now, one thing you need to do is add a database identifier. So you need to mark the database ID as a generated value. And actually, what I'm going to do is I'm going to make the database ID essentially generated via a identity generation column rather than the default, which I believe is sequence. And then I'm going to save that. And then the next thing I'm going to do is I'm going to annotate it with ID for the database ID. And now it's ready. Now, one thing that database IDs are normally nullable by default. So what I'm going to do is the ID column, I'm going to, when you first create them, the database has to assign the ID. So I don't actually want an ID when I create a new book. And what I can do is I can generate another constructor that doesn't have the database ID, and just assign that to null for when you create an initial entity without the database ID. And then I can annotate the constructor that I want to use to read from the database with @creator, and that means what that does is provide the hint necessary for the database to essentially know which constructor to invoke to create objects when reading them from the database. And it's really that simple. So I can have multiple constructors in this one annotated with creator. So now what I'm going to do is I'm going to create a new interface that's going to use this class, this entity called book repository. There it is. And I'm going to make it extend CRUD repository. And I'm going to pass 2 generic arguments. One is going to be book, and the other one is going to be the ID type, which is long. And then the only thing else I have to do is annotate this with @JDBC repository and specify dialect, which in this case is the Oracle dialect. So I'm going to add the Oracle dialect. And immediately I have the ability to perform CRUD operations just by extending CRUD repository from Micronaut data. So let's try this out in a test. So what I'm going to do is I'm actually going to create a new test. And I'm going to create a new JUnit test, and I'm going to create it in the test directory. And it's going to be book repository test, for example. And then what I'm going to do is place this test into a package. It's going to be in the com example. Book, and I'm going to give it a name, book repository test. There we go. And then next thing I'm going to do is I'm going to annotate it with @Micronaut test. And that will automatically make it a Micronaut test. Now I'm going to just create a test method that I'm going to use. So it's going to be a JUnit test. And into my test method, I'm going to inject my book repository class. And with the book repository class, I'm going to add an assertion here that asserts that the number of books is equal to 0. So obviously initially there's like 0 books in the database. So I'm just going to assert that there's like none of them. And now we're ready to run my tests. I'm going to run this and see what happens. Okay, so my test is passing, which is awesome. So obviously now if I want to make this test range string, we can save a new entity. So I can create a new entity and save it into the database. Something simple like stand. And what you can do is now change the assertion to insert that there's 1 book. And as you can see, when I run my test, it passes exactly as I expect, which is pretty awesome. So, and it's really nice how fast test executes, and you can navigate, for example, to Test Explorer and see all of the tests that you have and run them all and get feedback immediately. And the tooling is just phenomenal in terms of being able to do that right from VSCode and I can have that experience. Okay, so now I'm going to expose this data over a HTTP endpoint. So I'm going to create a new Java class, and it's going to be called book controller. and this is going to be my web controller. And I'm going to expose this over the books URI, HTTP URI, and I'm going to inject into it my book repository type. And I'm going to generate a new constructor. Then I'm simply going to add a get action that handles the HTTP get method that lists all of the books like this. And I'm going to return, probably I need to import Java util.list. And then I'm going to return repository.findAll, and that will return my, the only problem I think is that repository find all, I remember it returns iterable, not list, so that actually won't compile. So we have to go into my repository, and we can easily override methods just by generating an override, and override the final methods to make it, instead of returning an iterable, to return a list. Then switch back to my controller, and after I've done that, and you can see now that it's compiling and everything is working, which is really nice. So it's really that simple. So now let's go and write a test for this web controller and see how that looks. So I'm going to create another new test, and it's going to be in the same direction. It's going to be a book controller test, and I'm going to annotate it with Micronaut test once again, and I'm going to in this time, I'm going to test, what I'm actually going to do is going to define a book client interface, and it's going to annotate at client and point it to the book's URI. This is the way in Micronaut that you can easily define HTTP clients. And in fact, you can share method signatures between the server and the client, which is what I'm going to do here. And I'm going to invoke the client. And all I have to do is import apply the same imports here automatically. And now I have an automatic HTTP client. So let's write a test for this. I'm going to write a test that tests all the list books, and I'm going to inject my book client into this test and into this test method. And I'm going to call the list method to list all the books. And you can easily then select that and introduce a variable like that. And there you have the results. You just have to import the test annotation for JUnit5. And now I can write an assertion that asserts that I have no books right now. So I can just say, assert equals 0, 0 results.size, and there we go. There I have my test. Now let's run this and see what happens. As you can see, once I execute that, it's passing. So I've written a HTTP client, HTTP server, database application, all with very little code, and all very quickly. So let's take this even further now and add another endpoint to this book controller class, and let's add a get HTTP method once again. But this time, what we're going to do is we're going to look up the book by name. Like so, and we're going to find the book. We're going to find a book. We're going to define a find method, for example, or just call it find, I guess. It takes the name, and we're going to return repository find by name. Actually, it's not name; it's title. So I'm going to actually change that back. Because we don't actually have a name. It's actually called title. So the URI variable needs to be title. And we can auto create that method in my interface and pop over back to my repository to check that change out. So I'll just go and navigate. There it is. Okay, so I've got a find by title method that returns my book. And so one of the nice things about Micronaut that I want to point out is the type checking. So, we're using find by title. We've got a URI variable in here that uses the title property to query the database. And that's, there's some implicit handling here. So for example, this title variable has got a title parameter, that's bound to the title URI variable. And look, if I change the name of the title, you'll see, let's change it over there as well. You'll see that I get active type checking. It says the root declares a URI variable named title, but no corresponding method argument is present. So you can see that I get active type checking that I'm using the framework correctly. And won't let the application compile until I correct this error, which clearly the URI variable has to match the parameter, or there has to be a parameter, otherwise this is not a valid route. So I can correct that and change that back to title and fix the error. And the same thing happens as well with regards to my database access logic. So this is fine by title, but if I were to try change this, make a typo in my name, the title property, if we look at the book class here, the title property is modeled by the book class. That is the title property. But, so if I try to query like some other property that didn't exist, like from removing this E, you can see I get active type checking, compilation errors saying I'm doing this wrong. I cannot compile this, I'm sorry. So the developer can't create a faulty application by default. You will get a compilation error, which saves so much time in debugging and so forth. And it's just awesome how easy that is in Micronaut and how nice that is to do. So with that, let's have a look at another use case, which is validation. So I'm actually going to create another endpoint here called the post endpoint. And to save new books, I'm going to add a save method that's going to take the title and the pages. And I'm going to save an entity into the database for the title and the pages. Now, you might have constraints that apply to domain constraints that apply to these properties, and you don't want to save invalid data into the database. So what you can do is you can apply validation constraints to the title properties directly on your controllers, and it's all integrated into the framework using just JavaX validation. So I can add not blank. For example, I can add a max constraint. Or I think say that 50 is the max size. Well, actually, I think it should be size. I think it should be size. Yes, size and then max, like that. And you can apply constraints to that and ensure they're valid before they get passed downstream. And I can do the same thing on the pages. I can say this should be, maybe a maximum 10,000 page book is probably sufficient. You can't take any more than that. And, the pages must be positive, a positive number. You can't have like negative pages. That doesn't make any sense whatsoever. Probably need an import for that. So I get, active validation. And now, I've just easily added a post endpoint to like save that to the database. So I can come back to my my application here and actually test this out from a client and create some validators. So I can come in here into my controller, and I can add a method here that's going to post the data, and just need to fix these. I'm going to remove the constraints on the side. We don't need them because it's already validated on the server. And I'm going to just fix the syntax, add the imports, and correct the syntax here. And what we can do now is, with my client, I can just start saving results, right? So I can save the stand pages, and this is going to do an HTTP post across the REST call. I can get the result back, which is the book, like so, and I can provide an assertion here that the result is not null, like so, and now I can assert that the size is the right size. I need to remove this query to the right place after the save call to make this test pass. And now when I run this, the application, the test will hopefully pass, and it does. So I've really easily built an application here that is a database application with a REST UI, and it's all been made very stable and productive by the VSCode tooling and Micronaut. And of course, we can see failures as well. If I make this test fail, for example, you can see that we can really easily visualize test failures and see those failures come through when I'm running tests actively in the application. So I mean, a really awesome experience we have with the VS Code tooling.